This is a video about the basic properties of a parabola and some of the features that it has. So we'll go ahead and start with the most basic parabola, and that's the equation y is x squared. So y is x squared looks something like this. I have both a graph and a table of values over here. So if x is 0, we just square that and we get 0. 1 squared is 1, 2 squared is 4, 3 squared 9, so on and so forth. So we have a table of values over here, and if we plot those with a continuous curve, it looks something like this, or this U shape that's heading up. All parabolas will look like this no matter what. So any quadratic x squared plus anything times x plus anything will always take on this U type of shape. Sometimes it opens up, sometimes it opens down. It depends on the values, and that's what we'll be investigating here. So there are two different forms I want you to be aware of. One is this vertex form. Y is a times x minus h squared plus k. Sometimes this is referred to as standard form as well. So standard form or vertex form, popular names for that equation. And then also this general form. This is the one you're probably used to more. Y is ax squared plus bx plus c. The reason for the two different forms is that often we'll have this bottom one if things are multiplied out, and this top one is nice though if I'm looking for the vertex or trying to get an equation off of a graph. So we'll go ahead and look at both of those. Let's go ahead and start out with just how things change if I change some of these values in terms of the graph. So if I change this k value right here, move it over, let's say to 5. So now I have y is x squared plus 5. You'll notice the equation up here in parentheses. I still have that 0 just to remind myself the h is 0. But it's really just x squared plus 5. Notice everything just moved up 5 units. Okay, so that k value tells me how far up or down I'm going to move. So if I move it to 5, x squared plus 5, all these y values now are just 5 higher. So 5, 6, 9 instead of 0, 1, and 4. If I move it to, say, minus 5, right, so k is negative 5, x squared minus 5 moves everything down 5. So all the y values are now 5 units lower. The h will also change things as well. So let me go ahead and put the k back at 0. And we'll change this h. So now notice if I move my h, say over here to 4, we get y is 1 times x minus 4 squared, or just x minus 4 squared. If y is x minus 4 squared, notice which way the parabola went. It actually went to the right. The reason for that is that I want to see where this vertex or this bottommost point went to, and to do that I need to find where that 0, 0 went to. So I'm looking for what will make the inside of this parenthesis equal to 0. Alright, so we look on our chart and that y value equals 0 right there when x is 4. So 4 minus 4 is 0 squared. That puts it at 0. That's exactly where my vertex was before. So wherever my vertex y value was before, in this case 0, I want to find the x that's going to make that happen again. Alright, if I move it to h is, say, negative 4, okay, now notice we get an x plus 4 squared in parentheses. Now the thing that's going to make that 0 is a negative 4 for my x. Alright, so that translates into moving this left 4 units. So my vertex in this case is right there at negative 4, 0. Alright, any combination I want to do with these h and k's will tell me the equation and also where the vertex is. Alright, so if h is negative 4, k is negative 3, that looks like the equation x plus 4 squared minus 3. That will have vertex at negative 4 and negative 3. So just the h and k value right there. That's the nice thing about this vertex form, is that I can always get the vertex and most of the equation off of that. Now, if the a value changes, our vertex doesn't change, but some other stuff does change. So if I change that value of a, may have to move this over a little bit. That type of thing will change and to make it wider or narrow, but notice the vertex does not change. So we'll investigate those properties a little bit in the next video.